Right, a past paper question. So this was taken from Edexcel. It's a core mathematics question from C4 June 2008, and this was question number 4 of that paper. So let's have a read. A curve C has equation 3x squared minus y squared plus xy equals 4, and the points P and Q lie on the curve. The gradient of the tangent to the curve is 8/3 at P and at Q, and in part A we need to use implicit differentiation to show that y minus 2x equals 0 at P and at Q. So let's try part A. Let me try part A over here. So let me copy down the equation of this curve. So it's 3x squared minus y squared plus xy, and that is equal to 4. Now the gradient of the tangent to the curve is given, so it's 8/3 at P and at Q. So let's work out that gradient. So to work out the gradient we need dy over dx. So let's work out dy over dx, the gradient function for this equation. So the first step is we need to differentiate each term in this equation with respect to x. So we need d by dx of 3x squared minus, so a minus, we need d by dx of y squared plus, so a plus, we need d by dx of xy, and that is equal to, we also need d by dx of the right hand term, which is 4. So in this particular step we need to differentiate every single term in this equation, left hand side as well as right hand side, with respect to x. Now the derivative of 3x squared is straightforward, we'll get 6x. Likewise the derivative of 4 is straightforward, we'll get 0. However, let's differentiate y squared and xy with respect to x. So firstly, let me differentiate y squared with respect to x, so let me call that number 1, and then I'll differentiate xy with respect to x, let's call that number 2. Let's do these two as side calculations. So firstly, a side calculation for number 1, d by dx of y squared. Now to differentiate y squared with respect to x, we need to use the chain rule. So first we differentiate y squared with respect to y, and then we multiply by dy over dx. So once again we do this using the chain rule. So this is using the chain rule. Okay, so let's go one stage further. So let me continue over here. When I differentiate y squared with respect to y, it's 2y multiplied by, in this case, dy over dx. So 2y dy over dx for number 1. So that completes the side calculation for number 1. How about for number 2? So let's do another side calculation. So for number 2, d by dx, let me make that as neat as possible. So d by dx of xy. So xy are both functions in terms of x, and to differentiate a product of two functions of x we need to use the product rule. So let's use the product rule. So let me remind you of the product rule. D by dx of uv, that is v du over dx plus u dv over dx. So we're using the product rule here. So let me scroll below. So I'm going to take my u to be x, and I'm going to take my v to be y when applying the product rule. So a side calculation, so my u I've chosen to be x, so that would make du over dx 1, and v I'm taking that to be y, and let's work out dv over dx. So once again, we need to apply the chain rule to differentiate y. So first we differentiate y with respect to y, and then we multiply by dy over dx. So if I continue below, dv over dx, so that is equal to, when I differentiate y with respect to y, this is 1 times dy over dx, so that is dy over dx. So this is the side calculation for dv over dx. Previously I did a side calculation for du over dx. Let's substitute these into the product rule here. So let me continue below. So using the product rule, so let me continue over here, say d by dx, and d by dx of u is x, v is y. So that is equal to v, which is y, multiplied by du over dx, which is 1, plus, so a plus u being x, multiplied by dv over dx, which is dy over dx. So if I continue below, so if I get rid of the brackets, y times 1 is y, x times dy over dx is x, dy over dx. So this should be the solution to number 2. So we have the solutions to 1 as well as 2. So let's incorporate these into the main step here. So d by dx of 3x squared, that is 6x when differentiated. So let me scroll below. So we have 6x plus, and if I scroll above, well, it's minus rather. When I differentiate y squared, we have 2y dy over dx. So let me amend that plus, so it's a minus in actual fact. So minus, and let me use a bracket to be safe. So when I differentiate y squared, so if I scroll above, with respect to x, so we did that calculation here, so that we named number 1, we had 2y dy over dx. So if I scroll below, so we've got 2y dy over dx, close bracket. So let's scroll above. Plus, when we calculated number 2, so plus, and for number 2, here is the solution. So plus, opening another bracket, let's copy the result for number 2, y plus x dy over dx, close bracket. And if I scroll above, that is equal to, when we differentiate 4 with respect to x, the outcome is 0. So that is equal to 0 on the right. So remember the idea, we need dy over dx. So I'm going to keep the dy over dx terms on the left, and I'm going to bring the other terms over to the right hand side. So on the left hand side, I've got a minus 2y dy over dx. So minus 2y dy over dx, plus x dy over dx. So plus x dy over dx, and that is equal to, if I bring the 6x to the right hand side, that would become minus 6x, and if I bring the y to the right hand side, minus y. And now let me take a common fact of dy over dx. So if I factorize by taking a common fact of dy over dx, I'm left with minus 2y plus x in the bracket. That is equal to minus 6x minus y. So if I rearrange further, dy over dx, so that's going to be minus 6x minus y all over the minus 2y plus x. So that is the solution for dy over dx, the gradient function. So let's revisit the question. So remember, according to the question, it does say that the gradient of the tangent to the curve is 8/3 at P and Q. We need to use implicit differentiation in part A to show that y minus 2x is 0 at P and Q. So we have dy over dx, but the gradient is given at P and Q, it's 8/3. So if I scroll below, so let me make a note that since the gradient of the tangent at P and Q is equal to 8/3. So let me therefore equate dy over dx to 8/3. So dy over dx is minus 6x minus y over minus 2y plus x. Let's equate that to 8/3. And by rearranging this equation, let's see and let's hope that we're going to get to what we need to show, which is y minus 2x equals 0. So let's do some rearranging here. So if I keep these terms on the top and on the bottom in a bracket, and if I cross multiply, so through cross multiplication, I'll have 3 into minus 6x minus y, that is equal to 8 into minus 2y plus x. If we multiply the brackets, if we get rid of the brackets, 3 into minus 6x is minus 18x. 3 into minus y is minus 3y. That is equal to 8 into minus 2y is minus 16y. 8 into plus x is plus 8x. And if I move these two terms to the left hand side, so if we go back to the question, so I'm going to rearrange in a way so that the right hand side is 0. So I'm going to move my terms to the left hand side, and let's see what we're going to get as a result. So in this case, minus 18x minus 8x, that is minus 26x, and minus 3y plus 16y, that is a plus 13y, that is equal to 0. And I can reduce this equation, so if I divide every term in this equation by 13, so if I divide every single term in this equation on the left and on the right by 13, minus 26 divided by 13 is minus 2, so I'll have minus 2x. 13 divided by 13 is 1, so plus 1y, that is equal to 0 over 13 is 0. And I can rearrange this, so let me rewrite it as y minus 2x is equal to 0. And if I go back to the question, that's exactly what we need to show. So we need to use implicit differentiation, which we've done, and we need to show that y minus 2x equals 0 at P and at Q. So as you can see over here, we have indeed done that. So as required. So that completes part A. Now, if you're not aware of the principles behind implicit differentiation, I have created videos on my channel, and I provide links to those videos explaining the method and steps in the description below. So be sure to check out those videos. Now for part B. So part B, find the coordinates of P and Q. So we know that at P and Q, as a result of part A, y minus 2x equals 0. So let's do part B here. So we know that y minus 2x equals 0 at P and at Q. And we know the curve equation, so let's copy that down too. 3x squared minus y squared plus xy, and that is equal to 4. So what I'm going to do is let's rearrange equation 1, and so you can rearrange in terms of x or y, substitute that into equation 2 to work out one of the unknowns. So I'm going to rearrange equation number 1 in terms of y. So I'm going to make y in terms of x, substitute that into equation 2, and let's work out the x values first. So from equation number 1, y minus 2x is equal to 0, and if I rearrange this equation for y, so y equals 2x, and let me put y equals 2x straight into equation 2. So let's put y is equal to 2x into equation number 2. So by doing that, we're going to have 3x squared minus y, which is 2x, don't forget the power 2, plus the x, so plus the x, y replaced by 2x, and that is equal to the 4 on the right hand side. Now let's get rid of the brackets, so we'll have 3x squared minus 2x to the power 2, so that will be 4x squared. X times 2x is 2x squared, that is equal to the 4 on the right. And let's simplify the left hand side, so 3x squared minus 4x squared plus 2x squared is x squared, that is equal to 4, and if I take a square root on both sides, x will be plus or minus the square root of 4, which is plus or minus 2. So here are the x values, so we have 2 of them, x equals plus 2, x equals minus 2. We need to work out the coordinates according to part B of this question. So coordinates means we need the y coordinates corresponding to these x coordinates. So let's put these x coordinates into equation number 1. So I'm going to put it into the rearranged form of equation number 1, y equals 2x. So let's do that. So let me put the x values into equation, and let me call this equation 3. So 3 comes from 1, so 3 is the rearranged form for 1, and 3 is rearranged in terms of y. So I'm going to put it into equation 3 to work out the corresponding y values. So firstly, let's see what happens when x is equal to plus 2. So when x is equal to plus 2, y is equal to 2 into x, which is 2, 2 into 2 being 4. So this is the y value corresponding to x equals plus 2. And let's do the same for the other x value, which is minus 2. So when x is minus 2, y is equal to 2 into x, which is minus 2. 2 into minus 2 is minus 4. So just to summarize, we have 2 coordinates here. So just to summarize, when x is plus 2, the y value that corresponds to this is plus 4, and when x is minus 2, the y value corresponding to that value is minus 4. So this should be the answers for the coordinates, and these are the answers to part B of this question. So not only that completes part B, we've completed this question in its entirety. So I hope you liked this video, I hope you enjoyed this video. If you did enjoy the video, be sure to like and subscribe for more content like this, and I hope to see you again. Thank you.